Welcome to the Architecture Corner, where we unpack complex ideas and hopefully find those surprising insights. Today, we're diving into something super relevant for anyone building modern applications. It's all about tackling concurrency challenges in asynchronous systems.
Right. You hear it everywhere, don't you?
Yeah.
The world is asynchronous. It
Mhm.
was a big theme recently, I think, at AWS Invent.
Exactly. And it's true. I mean, managing multiple things happening at once without total chaos is, well, critical.
Absolutely. And what's fascinating, or maybe challenging, is how tricky that gets, especially when you use tools like AWS Step Functions for orchestration.
Yeah.
We'll be looking at a clever low-code solution outlined by one expert for exactly this kind of problem.
Okay, let's unpack this then. We've talked before about using SQS, standard queues for concurrency control. You'd think that would handle it.
You would think so.
But here's where it gets interesting, right? When that SQS queue triggers an asynchronous step function workflow, that maximum concurrency setting on SQS, it doesn't quite work like you'd expect. Why is that?
That's a really great point. It trips people up. The core issue is how these serverless pieces interact. See, the Lambda function that SQS calls to start the step function, it runs for a tiny fraction of a second, like priff, it's done.
Okay.
So the SQS concurrency limit, it only applies to that quick trigger function, not the whole step function execution, which could run for minutes, even hours.
Ah, right. So the gatekeeper, the SQS limit, only watches the front door for a second, but doesn't control how many people are actually inside the party long term.
Exactly. I've seen teams really struggle with this. They hit rate limits downstream and think they need to scale everything up.
I mean,
But
that's the
actually,
step functions themselves running wild.
precisely, you can end up with way more workflows running at the same time than you planned for. More cost, more strain on other services.
Okay, that makes sense. It's a critical distinction. So the real challenge isn't just starting the workflows, it's limiting the number of active tasks inside the step function itself.
Yes.
And this is where the semaphore idea comes in. How does that work as an internal traffic cop?
Yeah, exactly. The solution proposed uses a classic concurrency pattern, semaphores. Think of it like taking a ticket. An execution tries to acquire a slot from the semaphore. If a slot is available, it continues. If not, it waits. It's a way to control access to a shared resource or just limit parallelism.
Okay, like a limited number of passes.
Right. And what makes this approach particularly neat is moving the semaphore logic into its own separate step function.
Oh, interesting. Why separate it?
Well, it keeps your main business logic workflow clean. That workflow just calls this reusable semaphore utility. It promotes separation of concerns, makes things easier to manage.
That makes a lot of sense. Reusable patterns.
And there's another clever bit. Adding a TTL, a time to live, on the semaphore records in DynamoDB, which is typically used to store the state.
TPL, so they expire automatically.
Exactly. It prevents stale records from sticking around if something goes wrong, which avoids potential deadlocks down the line. It's just good housekeeping for concurrent systems.
Okay, that sounds incredibly practical. Let's make it concrete. Think about, say, a coupon redemption process. Lots of users trying to redeem at once. How would the semaphore pattern help there?
Great example. It's really versatile. Let's say you need workflow concurrency control. Maybe your coupon validation service, perhaps a third-party one, can only handle, say, 100 requests concurrently.
Okay.
You'd wrap the call to that service in your step function with a semaphore. You'd use a general key, like redeem coupon global, and set the limit to 100. That caps the total concurrent redemptions across everyone.
Got it. But what if I need to limit it per user? Like, only one redemption attempt per customer at a time to prevent double spending?
That's entity concurrency.
Yeah.
Also solvable. In that case, you'd use the user's ID as the semaphore key, maybe user 12345 redemption, and set the limit to just one.
Ah, so the key becomes specific to the entity.
Exactly. And you can even mix and match. You might have a global limit on the validation service and a per user limit on starting the process. You just use different semaphores with different keys in different parts of your workflow.
Wow, okay. That's really powerful, very granular control. But there are always trade-offs, right? Are there any limitations or things to watch out for with this DynamoDB-based semaphore?
Good question. Yes, it relies on DynamoDB, so you inherit its characteristics. Two main things to consider. First, DynamoDB items have a size limit, around 400 kVB. In practice, this means you can track maybe about 2,600 concurrent sessions per semaphore key before you might hit issues. That's usually plenty, but something to know.
2,600 per key is quite a lot for most cases.
It is. The second is write throughput. DynamoDB partitions have limits, roughly 1,000 write capacity units per second. Again, for many applications, this is fine. But if you have extremely high rates of processes trying to acquire or release the semaphore for the same key very rapidly, you might need to consider patterns to distribute the load. But for most typical workflow concurrency needs, it holds up very well.
Okay, so some scaling limits to be aware of, but they sound pretty high for common scenarios. It really seems like a solid pattern. So if you've got asynchronous, and let's face it, many of us have to bed, you simply must think about concurrency in your design. It's not an afterthought.
Absolutely fundamental.
And this solution, using semaphores managed by a separate step function, feels really elegant, especially because it avoids cluttering your main application code. Just infrastructure code, basically.
It really does save you headaches later on. And it makes you think, doesn't it?
About what?
Well, what other complex architectural problems, things we often solve with lots of custom logic, could actually be handled more elegantly with these kinds of low-code, pattern-based approaches using managed services?
That is a good question to chew on. Something for you, the listener, to think about too. For more details on this specific semaphore pattern and other architectural insights, definitely check out the description. And hey, don't forget to subscribe for free to the Architecture Corner newsletter over at architecturecorner.substack.com. We'll catch you next time.